All right, let's talk about something that's running the world behind the scenes, data engineering. It's this incredible art and science of taking a complete mess, a flood of information, and turning it into something clean, reliable, and seriously valuable. Let's dive in.
So, just to set the stage, think about this. Every single day, we generate an amount of data that is almost impossible to wrap your head around. We're not talking gigabytes or terabytes anymore. We are talking petabytes. That's thousands of terabytes every single day. That sheer scale, that's the core challenge. It's not a river of data, it's a planet-wide ocean.
So that brings us to the billion-dollar question, right? How on earth do you take that raw, chaotic ocean of data and actually refine it into something priceless, something that can power huge business decisions or even the next generation of AI? That's the puzzle we're going to solve today.
To even begin to answer that, we have to start with the fundamental tool of every data engineer. It's called the data pipeline. You can think of it as the factory floor where all this magic happens.
So what is it? A data pipeline is basically the plumbing that moves data from point A, say your phone app, through a bunch of cleaning and transformation steps, to point B, a database where it can actually be analyzed. It's like a data refinery. Crude, raw information goes in one end, and pure, actionable insight comes out the other.
Okay, so once the data gets into the pipeline, you've got a big decision to make right off the bat. How are we going to process this stuff? And this leads us to a huge fork in the road, the choice between batch and stream processing.
Think of it like this. Batch processing is like a giant cargo ship. It waits, collects a huge container full of data, like all of yesterday's sales figures, and then processes it all in one big scheduled go. It's super reliable for those massive jobs. Stream processing, though, that's more like a fleet of motorcycle couriers. Every single piece of data gets grabbed and processed the instant it shows up. This is what powers all that real-time stuff we love. Now, in that real-time streaming world, things can go wrong. A server might hiccup right in the middle of a transaction. And that's where this concept, exactly once semantics, becomes absolutely critical. It's a fancy term for a simple promise. No matter what fails or has to be retried, every single event will be processed exactly one time. Not zero, not twice, one. For your bank balance, this isn't a nice to have, it's everything. So, we've picked our processing style, but how do we design the whole system? You wouldn't build a skyscraper without a blueprint, right? Same thing here. In data engineering, we use architectural patterns to lay out the master plan for how everything fits together. For a while, there were two main schools of thought. First, the Lambda architecture. It's a two-lane highway, a slow, super accurate batch lane for historical data, and a fast speed layer for what's happening right now. It gives you the best of both worlds, but man, it can be a beast to maintain two separate systems. Then came the Kappa architecture, which basically said, why make it so complicated? Let's just use one super fast streaming lane for everything. It's way simpler, but you're putting all your eggs in one basket. So it's a classic trade-off. Do you want Lambda's resilience or Kappa's simplicity?
Okay, I know these architectures can feel a little heady, a bit abstract. So you might be wondering, is there a more intuitive way to think about this? A way that focuses more on the process of cleaning up the data?
And the answer is a big yes. Let me introduce you to the medallion architecture. I love this one because it's so easy to grasp. It just thinks about data in levels of quality. First, all the messy, raw data lands in a bronze table, untouched exactly as it came in. Then it gets cleaned up, filtered, and standardized, graduating to the silver table. And finally, it's rolled up into beautiful, business-ready summaries in the gold table, ready for prime time. It's just a clear, logical path from total chaos to perfect clarity.
Okay, so we have our blueprint. We know the path the data will take. But any good factory needs a manager, right? A foreman to run the assembly line, and a quality inspector to make sure the product isn't garbage. That's where orchestration and data quality come in.
Orchestration is basically the brain of the whole operation. It's the automated system that kicks off all the jobs, makes sure that task B doesn't start before task A finishes, and, crucially, knows what to do when something breaks. These workflows are often mapped out as a directed acyclic graph, or DAG. Don't let the name scare you, it's just a flowchart for computers. So, what's the absolute secret sauce to building a pipeline that can fix itself? It's this one golden rule: idempotency. An idempotent task is one you can run once, or 5 times, or 100 times, and it will always give you the exact same result. Why is that a superpower? Because when some random network error causes a job to fail, the orchestrator can just say, no problem, I'll run it again, without any fear of messing up your data. It's the key to automation that you can actually trust.
And what about that quality inspector? Well, a modern pipeline doesn't just cross its fingers and hope the data is good, it actively checks its work. It does schema validation, like, does this data have the columns I expect? It does statistical validation, are these numbers even in a reasonable range? And it looks for anomalies, flagging when something just looks weird. There are even cool tools like Great Expectations that let engineers write these checks as simple code.
So, building the pipeline is one massive project, but keeping it running smoothly, securely, and affordably day after day, that's a whole other challenge. Let's talk about keeping the pipeline healthy.
One of the biggest ongoing decisions is how to handle the data structure, or schema. The old school way is schema on write. It's very strict. It forces all data into a predefined box before it's ever saved. This guarantees quality, but it's not very flexible. The newer approach, common in data lakes, is schema on read. It just dumps all the raw data in as is and lets the user figure out the structure later. So you have this fundamental choice. Do you want to be a strict librarian up front or a flexible archivist who sorts things out later?
And of course, we got to talk about the money. Running these giant systems isn't cheap. So where does the money go? Well, the biggest chunk, usually about half, goes to compute. That's the raw processing power to actually transform the data. Then you have storage, which is pretty self-explanatory. And finally, there's the cost of actually running queries to get answers. Keeping an eye on all three is the key to not breaking the bank.
This field moves so incredibly fast. It is constantly changing to solve new problems. So before we wrap this up, let's take a quick peek over the horizon and see what's coming next.
And we're seeing some really fascinating trends emerge. There's this idea of a data mesh, which breaks up the central data team and lets individual business teams own their own data like a product. We're seeing serverless everything, where you only pay for the exact milliseconds you're using compute power. And for the AI world, we have things like feature stores to feed machine learning models. We're even seeing technology that brings the rock-solid reliability of a traditional database to the wild, flexible world of a data lake. It's an exciting time.
Which really leaves us with this one big thought. As literally every part of our world becomes more and more built on data, for every decision, for every new piece of AI, the pipelines that move and refine that data are becoming the most critical infrastructure we have. The question isn't if we'll need them. The question is, who's going to build them? Who's going to build the robust, reliable, and truly revolutionary pipelines of the future?